Hello, this is Mr. Stone. This video is about energy and chemical change. After watching this video, you should learn how to compare and contrast endothermic and exothermic reactions, as well as identify forms of energy in a chemical reaction. This is important because energy-producing reactions help us understand about heating or cooling our homes. They help us understand how to cook our food, and energy-producing reactions are involved with moving us from place to place. Remember, a chemical reaction is when atoms rearrange to form new products. The rearrangement of atoms involves some form of energy. In most cases, the energy is heat. In explosive chemical reactions, like what we see in fireworks or in a rocket launch, the energy produced is in the form of sound, light, heat, and the movement of matter. Some reactions give off light with almost no thermal energy or heat. The light stick is a plastic tube with a glass vial inside. When the plastic tube is bent, the glass vial breaks. This causes chemicals contained inside the tube and the vial to mix and react. When they react, the stick glows with cold light. Cold light occurs at room temperature. It is called cold light because its temperature is lower than the temperature of an incandescent light. You may have seen fireflies flash their beacons of cold light on a summer night. The ocean-dwelling organisms also produce cold light. So we might wonder, where does the energy of explosive reactions and cold light come from? Well, it's stored in the reacting molecules. So the energy changes into other forms such as light energy, heat energy, sound energy, or energy of motion. Just as mass is conserved in chemical reactions, so is energy. The law of conservation of energy tells us that energy is neither created nor destroyed in chemical reactions. The energy simply changes its form. This example is stored chemical energy in a battery, which, when put into a flashlight, can be converted and changed into light energy. The energy in all chemical reactions relates to the chemical bonds. When atoms rearrange in chemical reactions, bonds are broken and new bonds form. Breaking bonds requires energy. Forming bonds releases energy. If less energy is required to break the original bonds than is given off when new bonds form, there is a net release of energy. An exothermic process releases energy. This released energy can be in the form such as light, sound, and heat. The products of an exothermic process have less energy than the reactants. Notice in the diagram that the reactants have a higher energy than the products. This athletic hot pack is a great example of an exothermic process. When a hot pack is activated, the process that occurs releases heat to soothe our sore muscles. Understanding this release of energy, engineers are designing cars to conserve gasoline by dividing the energy needs of an automobile between gasoline engines and electric motor powered by batteries. Sometimes the energy required to break bonds is greater than the energy when new bonds form. In these processes, there is a net absorption of energy. An endothermic process absorbs energy. Notice in this energy diagram, the reactants are lower in energy than the products. That means the reactants are more stable than the products. In athletic cold packs, the endothermic process is when the ionic salt ammonium nitrate is dissolved in water. This causes the liquid to become extremely cold. The decomposition of water is another endothermic reaction. Electrical energy must be supplied to cause the reaction to occur. The products hydrogen and oxygen are at a higher energy than the reactant water molecules. More energy is stored in their bonds than in the bonds of the water molecules. The most simple way to compare exothermic processes with endothermic processes Remember exo, this is the idea of going out. Heat is released. Endo, it's coming in, so heat is absorbed. Exothermic reactions will release energy, so they will feel hot. Endothermic reactions absorb energy, so they will feel cold. Now that you've watched this video, can you compare and contrast exothermic reactions with endothermic reactions? Also, are you able to identify different forms of energy in a reaction? This is Mr. Stone. I hope this video helped.